Ever watched a video and wished you could step inside it? Like really step inside, zoom around, flip perspectives, or relive moments from a different angle. That's the promise of 3D reconstruction, and today we're diving into a breakthrough called StreamSplat that's turning that vision into reality. Let's start with the problem. Traditional methods for converting videos into 3D models. They're like trying to build a house with a broken ruler. If the camera isn't perfectly calibrated, like when it's shaking, moving erratically, or capturing fast-moving objects, these systems struggle. They either freeze the action, blur details, or crash under the weight of long videos. But StreamSplat, it's like giving a computer a superpower. Instead of relying on perfect camera data, it uses 3D Gaussian splats. Think of them as digital paint droplets that float in space. Each droplet holds color, depth, and opacity, and together they form a 3D scene. The magic. These droplets don't just sit still. They adapt in real time, even when the camera is wobbling or the scene is chaotic. Here's how it works. StreamSplat breaks down each video frame into tiny 3D blobs and uses probabilistic sampling to guess where they go. Instead of one rigid answer, it considers multiple possibilities, like a GPS that suggests several routes instead of just one. This reduces errors and lets the system explore better solutions. But what about moving objects? That's where bidirectional deformation fields come in. Imagine a video that can move forward and backward in time. StreamSplat predicts how objects shift between frames in both directions, keeping everything smooth even when cars zoom by or people dance. No more jumpy 3D models. Now let's break down the architecture. StreamSplat operates like a movie crew. An image tokenizer slices frames into tiny pieces, a static encoder locks onto what doesn't move, a dynamic decoder brings motion to life, and an upsampler polishes the final result. Think of it as a team where some focus on the scenery, others on the action, and one ensures everything looks crystal clear. The math gets clever here. StreamSplat uses Gaussian tokens, digital building blocks that predict 3D details like object positions, sizes, and colors. But here's the twist, it doesn't just guess. It uses probabilistic position sampling, like a GPS that recalculates your route in real time instead of getting stuck in a loop. This keeps things smooth, even when things get chaotic. StreamSplat learns from massive datasets like Co3DV2 and YouTube VOS, which include everything from daily life to fast-paced action. The results? It outperforms other systems, especially with fast motion or occluded objects. It's like giving an AI a superpower to track the world in real time. But no tech is perfect. Right now, StreamSplat relies on pseudo-depth maps, blurry snapshots from other tools. Sometimes they're noisy, like trying to spot a friend through a foggy window. Researchers are already tweaking this, using adaptive training to make things clearer. Also, it's better at short-term motion than long-term changes, but every innovation starts with a first step. Why does this matter? Picture autonomous cars, seeing 3D scenes to navigate safely, or VR systems crafting worlds so real you'll forget you're wearing a headset. The potential is huge, even with edge cases still in play. So next time you watch a video, remember, behind the scenes, AI is rewriting the rules of how we see the world. And this is just the beginning. Thanks for watching. If you want more deep dives into the science shaping our future, hit that subscribe button. Until next time, stay curious.